Hello, fourth grade. Welcome back to math. We're going to be starting a new chapter today, chapter 20. In this chapter, we'll be working on a lot of vocabulary for math, so it's going to be very important that you write down this vocabulary in your journal so you can come back to it at any time. So at this point, I'd like you to make sure you have your journal out, have it labeled 20.1 points, lines, and rays. Have your textbook open to page 518. I'd like you to pause the video, write down this vocabulary and draw the pictures for example, then unpause and we'll continue together. Alright, so you should have paused the video by now. Let's go over the vocabulary that you have just written down. So this entire lesson today is based on these vocabulary words, so it's very important that you understand the difference between each. So we're talking about points, lines, and rays today. A point names an exact location. An exact location. So a point is literally just a dot in space. A line segment is a part of a line. It has two endpoints at the end. We call those endpoints. The D and the E would be endpoint D and endpoint E. We would call this line D, E, and we do that by writing a line over the top of it and labeling it with its endpoints. Now a true line, not a line segment, but a true line is a straight path of points that continues in both directions forever. So it has to be straight, so we notice that this is straight, and do you see these arrows at the end? That means that it is continuing forever. That's the definition of a line. A ray is similar, except it has one endpoint and one side that continues forever. A plane, P-L-A-N-E, plane, is a flat surface that continues in all directions forever. So you've heard of our plane shapes, like squares, circles, triangles. That's what a plane is, but the true definition is that it can continue in all directions forever. It's a little bit hard to imagine, but that is true. All right, so you don't need to copy this down. This is coming from your textbook, so you can always go back to look. As you can see, similar to what I just had you jot down, but a little bit different in the sense that it tells you how you can read it and write it and examples of those in real life. So this page in your textbook would be a great resource for you as you go throughout this lesson. If you would like to pause and add some sort of notes in your journal, you may, but you do not have to. Okay, so let's continue forward. And, before we do that, let me make sure you understand how we say these different things. So point, we just say point A. Line segment, we say line segment DE or ED, depending on the endpoints. Same thing with lines, we label it by the points on the line. Ray, same thing, we say ray and we label it by the points on the ray. And then planes, it has to have at least three points so that we're able to label it. So this would be plane KML or LMK. As long as you have 3 points, you can label it and you just say the word plane before it. The shortened way to write it is you draw a little picture above the letters of what it looks like. So like this is a line, BC, do you notice there's a little line above it? This is a ray, you notice there's a small ray above it. This is just a line segment, you notice there's just a line segment above it. The only ones that get an actual label are points and planes. Alright, let's start practicing. You'll need that vocabulary handy because, like I said, this entire lesson is all based on vocabulary. So, number 1 says, name the figure at the right. Well, I see a line, but it has two endpoints. What is it called if the line does not continue in all directions? It's not a true line, it's actually a line segment. So let's go ahead and draw that line segment. This is line segment AD. Please draw with me. And to name it, it's a line segment. So we can write line segment. That's how we read it. And how we write it is we write the letters of the endpoints and then we draw above it what it is. So line segment AD, write AD, and then a line segment above it. All right, moving forward. Number 2 through 5 says name a geometric term. Those are the vocabulary words that we just wrote down. Name a geometric term that best represents the object. So think about number 2 is the tip of a tack. Think about the tip of a tack. Would that be a ray, a line segment, a line, a point, a plane? What do you think? The tip of a tack that you use to post things up on boards with. It would be a point. A tip of a tack would be a point because it just comes to one point. Quite literally, it has a point on it. Number 3, a train track rail. So think about chugga chugga choo choo, train tracks. What do you think? A line segment, a ray. Does it continue on forever or does it have a stopping point? It does have a stopping point, so a train track rail would be a line segment. Number 4. Number 4 is a flagpole. So again, think of a flagpole. We can even draw one. Ooh, flag. So this here is a line segment, a ray. Does it continue forever in both directions? What do you think? Does it continue in one direction forever? No. So that would make it just a line segment. All right, number 5, a laser beam. A laser beam. So a laser beam normally comes out of a small contraption and it shoots off light that will go on forever until it's interrupted by something like a wall. But otherwise it will go on forever. So this is a good example, a laser beam, of something that does continue on forever unless it's interrupted. Would this though be a line segment, a ray, or a line? So let's think. Lines continue on in both directions. Is this continuing in both directions? No, it's only continuing in one direction. So the term that says a line that continues in one direction but not the other is called a ray. So that is a ray. All right, for numbers 7 through 10, we're going to continue naming the geometric term that best represents the object. So number 7 is a one-way arrow. So think at a stoplight, a one-way arrow would look like that. What geometric term does that look like? It looks like a ray. It continues in one direction, but not in the other. All right, number 8, a tip of a marker. So this is similar to that tip of a tack. Do you remember what that one was? A tip of a marker comes to just a point. This is called a point. Number 9, a parking lot. Well, a parking lot is flat, so definitely not a line. What is the only one that has more than 3 points and continues in all directions? That's called a plane. A parking lot would be a plane because it continues in more than one direction. It's made up of line segments, which is part of what makes it a plane. All right, number 10. the edge of a desk. So let's think about a desk and just the edge of it. What would that be? A line segment, or a ray? Well, I don't see that it's continuing in all directions. I see it has stopping points, 2 endpoints to it. So would that be a line or a line segment? That would be a line segment. You guys are doing a great job, I'm sure. Let's keep going. All right, 11 through 14, we are now going to need to think of everyday objects that represent the terms, the geometric terms. So this can be, it's like reverse of what we were just doing. We need to think of the object, they give us the term. So number 11, a line. So think of something that is a line that continues in both directions forever. Both directions forever. So when I think about this, I think about a building, and I think about the windows on the building. And I think that if I were to draw a straight line across the building below the windows, that line would continue on forever, even though the only part of it that I can physically see is the bottom of the window. But if I drew a straight line across that to meet the bottom, that would continue on forever. All right, number 12, a line segment. Now, most of the things that we think are lines are actually line segments because they have 2 endpoints. So a line segment, that could be like a pen or a pencil. The edge of my pencil has a line segment. It has a stopping point. All right, number 13, array. Array. So array continues in one, it's a line that continues in one direction forever. So we already heard about a laser beam. That's a really good representation of array. Another one that looks like array is, what I'm thinking of, is a clock hand. A clock hand starts with at one place and then it has an arrow showing it's continuing. So a clock hand would be another good example of array. All right, number 14, a plane. Well, this is any flat surface that continues in all directions. So it could be the top of a desk, the top of a table, a wall. I'm going to write a wall for mine. A plane is any flat surface that continues in more than one direction. All right, so now we're going to practice drawing some of these geometric terms. So I have this dotted figure. You might want to pause the video and make yourself a dotted figure in your journal. Maybe make it about 10 by 10 dots. Go ahead and pause, make yourself that, and then unpause and continue with me. All right, so let's keep working together. So you should have a dotted figure so that we can draw these lines and segments. So number 15 says draw line XY. So line XY needs to have points on it, X and Y, and it needs to continue in both directions. So on your grid, let's go ahead and draw, label one point X, and label another point Y. This is line XY. And then it needs to continue past those points in both directions. So it has the points on there, XY, and it's continuing in both directions. This is number 15. Okay, number 16. Number 16 says point H. So a point is just a point in space. So all I need is to draw a point and I need to label it H. Easy peasy. Number 17. Ray MH. N. So again, it needs to have the points MN. So go ahead and do those first MN. Label the points M and N. Now a ray continues in one direction forever. So go ahead and continue it past point N and draw an end arrow, but do not do that at M. A ray only continues in one direction. All right, and last but not least, plane PQR is number 18. So go ahead and draw out point P, and then somewhere else draw point Q, and somewhere else draw point R. Then go ahead and draw any shape around those beyond the points. So I'm going to draw a rectangle. And a plane is an enclosed figure. It has no breaks in the lines, so make sure yours also does not have any breaks in the lines. All right, moving on. So we're going to look at a real-life object and see if we can name some geometric figures and terms from the picture. So this is a picture of a building under construction. So I'm going to look at number 19. It asks me what geometric term describes where two walls and a floor meet. So think about maybe even look in your house. So think about two walls and a floor. So that would make a corner, right? We would see, so number 19, two walls meeting in your house. And the floor, that point where they're meeting, what would be the geometric term to describe that? Two walls are meeting with the floor. It makes a corner. That would be a point. So number 19 is point. Where two walls and a floor meet would be a point. So now let's take a look at the picture for number 20. What features on the building show line segments? So we see a lot of lines on here. So which ones would be line segments? Well, there's a lot of them. I see these red bars at the top. Those are all line segments. I see lots of cross beams. Those are line segments. I see lots of support beams. Those are all line segments. Lots and lots of line segments on number 20. We don't need to write that down, but those would be all line segments. All right, we're going to skip down to number 23. It says, explain how you know which path is the shortest distance between C and D. So let's go ahead and copy these down. This is number 23. So we have one line that has C and D and it's curvy. And then we have another one that's C and D and it's straight across. So which one would be the shortest path? The first one that's curvy or the second one that's a straight line? Well, the one that's a straight line would definitely be shorter because we're not traveling any extra distance. To get from C to D, we went straight. The first figure went up and then down and then across. If I took these dots that I just made here and I tried to straighten them all out, it would be a lot of extra space. So for example, I'm going to go ahead and continue this, counting the number of dots. So I just straightened out that curved line. And I can see, I messed up some of my dots. If I take this, I got D, I'm sorry, one moment. Redo. Now, if I measured that with my line CD, you can tell obviously that that was a longer route. The shortest distance between 2 points is called a line. So any like curving and zigzagging that's done adds extra distance. A line segment is the shortest distance between 2 points. All right, class. So this week and the weeks following are going to be a little bit different. We're still going to do an assignment a day. You're still working on happy numbers, but also I'm going to be posting the answers for you at the end of the video for your practice work. The reason why is we're not having any more pickup drop-off days, so you completing your work is for practice and is for learning, but I'm not going to be collecting your work to grade it. Instead, I'm going to be asking what you complete at the end of the week, and I'm going to be posting some quizzes. So you can't do well on the quizzes if you haven't finished the work, right? So you'll need to do your work and do the learning with me. And I have the answers here so that you can check your work once you're done, so that you're getting that feedback since I'm not going to be collecting your work anymore. So this is still an assignment. You need to do 20.1. You will get docked down if you don't complete it, so you do need to complete it and do your best. But the answers are here for you so you can check and make sure that you're on the right track. And then at the end of the week, I'll send out a quiz over what we've been talking about, and you'll need to complete that also for points, okay? So the answers are here for you to check your work. So I would suggest that you pause the video, close up your device, go do your work, and then come back and check your answers. Now you'll notice not all of them are filled in because some of them today it could be various different answers. So if you need help, go ahead and ask mom or dad, or wait till our Zoom call and you can run your answers by me, okay? Keep working hard, and I will see you soon.